Welcome to this tutorial on surfaces and orbitals in Jmol application. In this tutorial, we will learn to create models of alicyclic and aromatic molecules, display different surfaces of molecules, and display atomic and molecular orbitals. To follow this tutorial, you should know how to create and edit molecular models in Jmol application. If not, watch the relevant tutorials available at our website. To record this tutorial, I am using Ubuntu operating system version 12.04, Jmol version 12.2.2 and Java version 7. I have opened a new Jmol application window. Let us first create a model of cyclohexane. Click on the Model Kit menu. A model of methane appears on the panel. To create cyclohexane, we have to make a hydrocarbon chain of 6 carbon atoms. We will substitute the hydrogen in the model with a methyl group. To do so, we will place the cursor on the hydrogen and click on it. This is a model of ethane on screen. Repeat this step another 2 times and replace one hydrogen at a time with a methyl group. Click on the hydrogens in such a way that the structure forms a circle. Now rotate the structure on screen using the Rotate Molecule tool. This is the structure of butane on the panel. Click on the Model Kit menu. Click on hydrogen on any of the carbon atoms present at the end of the chain. Here is a model of pentane on the panel. Click on one of the hydrogens that is close to the end of the carbon chain. A model of cyclohexane is created on the panel. Use Minimize option in the Model Kit menu to optimize the structure. The model of cyclohexane is now in its most stable chair conformation. Alternately, we can also use Drag to Bond option in the Model Kit menu to create cyclic structures. I will use a model of pentane to demonstrate this feature. This is a model of pentane on the panel. To convert this into cyclopentane, select Drag to Bond option from the Model Kit menu. Place the cursor on the carbon present at one end of the chain. Hold down the mouse button. Without releasing the mouse button, bring the cursor to the carbon present at the other end of the chain. Now release the mouse button. We have a model of cyclopentane on the panel. Now let's go back to the Jmol panel with a model of cyclohexane. Let us now convert cyclohexane to a benzene ring. We have to introduce double bonds at alternate positions in the cyclohexane ring. Open the Model Kit menu. Place the cursor on the bond between any 2 carbon atoms and click on it. We now have cyclohexene on the panel. Next, we need to introduce 2 more double bonds in the structure to convert it to benzene. Click on the bond between the next 2 alternate carbon atoms. We have a model of benzene on the panel. Do the energy minimization to get a stable conformation. Surface topology of the molecules can be displayed by using Jmol application. To view different surfaces, open the pop-up menu. Ensure that the Model Kit menu is closed if it is open. Now right-click on the panel to open the pop-up menu. Scroll down and select Surfaces. A sub-menu opens with many options: dot surface, van der Waals, and some others. For demonstration purpose, I will select molecular surface. The model of benzene is displayed with a molecular surface. Let us change it to another surface, say a dot surface. So open the pop-up menu again and choose dot surface. We can also make the surfaces opaque or translucent. To do so, open the pop-up menu, scroll down to Surfaces and select Make Opaque option. Observe that the benzene model has become opaque. To turn off the surface option, open the pop-up menu, choose surfaces, scroll down to off and click on it. Now we have a model of benzene without any surfaces. Jmol can display atomic and molecular orbitals of molecules. Atomic orbitals can be displayed on screen by writing commands on the console. Open a new Jmol window by clicking on File and New. Now open the console window by clicking on File and then on Console. The console window opens on the screen. I am using Kmag screen magnifier to magnify the console window. The command line for the atomic orbitals starts with isosurface phase atomic orbital. At the dollar prompt, type isosurface phase atomic orbital. This is followed by quantum numbers n, l and m that are specific for each atomic orbitals. To display s orbital, type 2, 0, 0. The numbers 2, 0, 0 represent n, l and m quantum numbers respectively. Press enter key to execute the command. We have s orbital displayed on the panel. Here are few more examples of atomic orbitals and the corresponding script commands. The command line is same for all atomic orbitals. To display the previous command on the console, press up arrow key on the keyboard. Edit n, l and m quantum numbers to 2, 1, 1. Press enter key and see the px orbital on the Jmol panel. Press up arrow key again and edit n, l and m to 3, 2 and -1. Press enter key and see the dxy orbital on the Jmol panel. We can also save these images in different file formats like JPG, PNG or PDF. Here is a list of commands for all atomic orbitals S, P, D and F. Shown on this slide are models of atomic orbitals. They were created with the help of script commands written on the console. Here I have opened a new Jmol panel and console to show how to display molecular orbitals. Hybridized molecular orbitals such as sp3, sp2 and sp can be displayed using Jmol. We have a model of methane on the panel. Methane has molecular orbitals of the type sp3. Linear combination of atomic orbitals, that is LCAO method, is used to create molecular orbitals. So the command line starts with LCAO cartoon followed by create and the name of the orbital. At the dollar prompt, type LCAO cartoon create sp3. Press enter. Observe the model of methane with sp3 hybridized molecular orbitals. To display sp2 hybridized molecular orbitals, we will take ethene as an example. This is a molecule of ethene on the panel. Ethene molecule has 3 sp2 hybridized molecular orbitals. They are named sp2a, sp2b and sp2c. At the dollar prompt, type LCAO cartoon create sp2a. Press enter. Observe the sp2 orbital in the ethene molecule on the panel. Press up arrow key and change sp2a to sp2b. Press enter. Again, press up arrow key and change sp2b to sp2c. Press enter. Finally, for the pi bond, edit the name of the orbital as pz. On the panel, we have ethene molecule with all the molecular orbitals. This slide shows examples of few other molecules with molecular orbitals. Explore the website for Jmol script documentation for more information. Let's summarize. In this tutorial, we have learnt to create a model of cyclohexane and cyclopentane, create a model of benzene, display surface topology of molecules. We also learned to display atomic orbitals s, p, d and f, display molecular orbitals sp3, sp2 and sp by writing script commands on the console. Here is an assignment. Create a model of 2-butene and display molecular orbitals. Explore LCAO cartoon command to change the color and size of molecular orbitals. Refer the following link for list of commands. Watch the video available at this URL. It summarizes the spoken tutorial project. If you do not have good bandwidth, you can download and watch it. The Spoken Tutorial Project team conducts workshops using spoken tutorials, gives certificates to those who pass an online test. For more details, please write to contact@spoken-tutorial.org. Spoken Tutorial Project is a part of the Talk to a Teacher project. It is supported by the National Mission on Education through ICT, MHRD, Government of India. More information on this mission is available at this link. This is Snehalata from IIT Bombay signing off. Thank you for joining.